Hey, grade sevens, we are starting our next unit on probability, which is one of my favorite units. Probability is super interesting, and some things are, you can look at some things that are pretty like astounding that we see happen. Because probability, we're really looking at any event when you say like, what are the chances that that happens? Usually, you can figure the chances out using some of the things that we're going to be learning in this unit. You'll be continuing to do probability into high school and look at lots of different things, and it's a sort of neat thing, neat part of statistics. So just quick definition: probability is the likelihood or chance of an event occurring. And we have this equation here that probability is equal to the favorable outcomes divided by the total possible outcomes. Okay? And this is the equation that we're sort of always going to be referring back to for probability. The favorable outcomes, the outcome that you're looking for, divided by the total possible outcomes that could happen. And these probabilities can be expressed as a ratio, as a fraction, or a percent. Remembering that ratio, fractions, percents, decimals, they are all just different ways of showing the same number. So we're going to just look at some situations here and look at these probabilities. So if we have a number line, this number line goes from 0 to 1. Okay, so it's sort of a short number line. But actually, all probabilities are essentially going to fit into this number line, just between 0 and 1. Because 0 as a percentage is 0%. And you can't have less than a 0% chance that something will happen. And 1 as a percentage is 100%. And you can't really have more than a 100% chance of something occurring. If it is going to occur, that's 100%, and you can't have it, like, occur more than that 100%. So all probability falls in between here. And we can write things as fractions, as shown at the top here: 0, 1/4, 1/2, 3/4, 1. There would be other fractions in between here. For example, 78 out of 79 would be right near 1. It's a random fraction, but it's right less than 1. You could have just over half would be like 26 out of 50 would be just over half. So that would come in right here. And you could have any fraction, which could then be turned into any decimal. But we're mostly just going to be working with these regular basic ones. So 0 as a decimal is just 0.0, or just 0.0. 1/4, 0.25 is a percent. That's 25%. You multiply the decimal by 100. So 0.5, 1/2, that's 50% of the time. 50% is half. 3/4 is the same as 75%, which is the same as 0.75. And 1 is the same as the decimal 1, which is the same as 100%. So all probabilities of things would fall in these. So let's look at some of these situations here. So estimate each of the following probabilities here. Mark and label each event where it should be on the number line. So A, you flip a Canadian penny. It has two sides. It lands with the maple leaf facing up. Well, lands with the maple leaf facing up. That's sort of the favorable outcome. So there's one favorable outcome with the maple leaf facing up. How many outcomes are there? Well, it's heads or tails, or maple leaf, or the queen's head. So that's 1 out of 2. So this event would be right here, A. Okay, what about B? You roll an 8 on a 6-sided die numbered 1 to 6. Okay, so the favorable event that we're looking for is rolling an 8 on a die that only has numbers 1 through 6. Well, there are 0 favorable outcomes on that die. You cannot do that. And there's 6 possible outcomes, so that's 0 out of 6. So that would be 0%. So that event B would be here. Okay, C. A bag contains 8 red markers. You reach into the bag and you pull out a red marker. Okay, well, if you reach into the bag, there's 8 red markers. There's 8 possible outcomes, right? 8 different markers you could choose, but they're all red. So getting the outcome that it's red, it's an 8 out of 8 chance or a 100% chance. So that event would be over on the right side by the 1. Okay, D, you spin a spinner with 4 equal sections marked chocolate, fruit, frozen yogurt, and ice cream. The pointer stops on fruit. So that pointer could have stopped on 4 different places. It stopped on that one of them, fruit, so that's 1 out of 4. And so that's going to be here. D would be here at 25%. Okay, E, a bag contains the letters A, B, C, D, E, F, G, H. So 1, 2, 3, 4, 5, 6, 7, 8 different letters. Right, 1, 2, 3, 4, 5, 6, 7, 8. You reach your hand in the bag. So there's 8 different possible outcomes of what you could grab. You could grab any one of those 8 letters. You pull out the letter H. So you get a 1 out of 8 chance of getting the H. So that would actually be in between here. 1 out of 8 would be here. So E would be here. Okay, and scroll down a little bit. So F, a bag has 3 silver marbles, 1 gold marble. You put your hand in the bag, and you pull out the gold marble. When you put it in, there's 4 different marbles that you could pick. So you actually had 4 possible outcomes. 3 of those possible outcomes were silver, but 1 of them was gold. So that was a 1 out of 4 chance. So F would also be here by 25%. And lastly, the next baby to be born in your town will be a boy. Well, assuming that it will be either a boy or a girl, there's a 1 out of 2 chance. And so G would be at 50%. Okay, so we can look at some situations and just sort of make an estimate of where they would be on that number line. Okay, so we're representing probabilities. We're going to have this spinner here. It has 5 equal sections. Being equal is important because then there's an equal chance that each one of them would happen. And that's what you need for something to be random, is that there's an equal chance that each could happen. If you had a spinner and it just had one tiny sliver and then the rest was all one section, you couldn't say it's random which one it lands on, because it's actually skewed very much that it would land on the bigger portion. Whereas when they're all equal, then it can be more random. So we want to write each answer as a fraction, ratio, and a percent. So A says, what is the probability of spinning an A? Well, there's one A, so that's our one favorable outcome. And there is 5 possible outcomes, so it's 1 out of 5. And I'm actually going to say, the notation that we use is to say, okay, the probability of, and then you put in brackets, so the big P is probability of A, probability of getting an A is equal to, well, there's 1A out of the 5 outcomes. We could write this as a ratio as well, which would be 1 to 5. Or we could write it as a decimal. 1 divided by 5 is 0.2. You could write it any of those ways. Okay? So B, what is the probability of spinning a vowel? So B, what is the probability of a vowel? Okay, so this is the sort of notation that we're using. Big P for probability. Then in brackets, you have what your favorable outcome is, what you're looking for. What's the probability of getting a vowel? Well, there are just the A and the E are the only 2 vowels. Vowels are A, E, I, O, U, sometimes Y. So there's 2 possible favorable outcomes out of the 5 total possible outcomes. We could also write this as 2 to 5 as a ratio, or as 0.4. For the most part, we're going to be sticking with fractions, but we'll also sometimes be doing decimals. Ratios, not as often. Okay, and then what is the probability of spinning a Q? So C, whoops, the probability of spinning a Q, when we look at the possible outcomes, there are no Qs possible. So there are 0 favorable outcomes out of the total possible outcomes. So 0 favorable out of the total possible ones. There are 5 total possible ones, so 0 to 5, which is equal to 0 to 5, which is equal just to 0 as a decimal. Okay, fairly straightforward. I think most of you are probably getting that. Let's look at another situation. A bag contains 10 marbles. Show the probability of the events as a fraction ratio, and instead of decimal as a percent. So what's the probability of A selecting a red marble? Well, the probability of getting red is, well, there are how many favorable outcomes in this situation? Well, there are 1, 2, 3, 4, 5, 6 red ones. So there's 6 favorable if we're looking for red, out of the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I guess it said 10 marbles. So 6 out of 10, which is the same as 6 to 10. 6 out of 10 is the same as 60%. So you have a 60% chance of picking a red if you're not looking. B, what's the probability of selecting a red or blue or green marble? So probability of red or blue. I'm just going to just show. Sometimes we'll say R or blue. They'll just show a letter representing or green. So if we wanted red or blue or green, any of those are favorable, which means that any single marble here is favorable. So that'd be 10 out of 10, which is a 1-to-1 ratio if you simplify it, which is the same as 100%. Okay, and lastly, C, what is the probability of not selecting a red marble? What's the probability of not red? So not getting red is favorable now. So any other one but red is favorable. So the not reds, we have 1, 2, 3, 4 marbles that are not red. So it'd be 4 favorable outcomes out of the 10 possible outcomes. That could be simplified as 4 to 10, which is the same as 2 to 5, which is the same as 40%. Okay, so if that makes sense, this notation is something that you'll have to get used to and just understand. The big P means what's the probability of whatever, and then we're looking for that outcome that is inside there. That's the favorable outcome. Okay, just quickly looking at these key ideas, your probability is the favorable outcomes divided by the possible outcomes. Okay, this is the main thing. And then you just look at how many, in this case, if you're looking for probability of red, P red, you would have all of those, how many of those outcomes are favorable, all those red ones, divided by all of the possible outcomes, including those red outcomes as well. Okay, so it's not just comparing favorable outcomes to non-favorable outcomes, it's favorable outcomes divided by all possible outcomes. So probability can be written as a fraction ratio percent. We've gone over that. The probability of an impossible event is 0 or 0%, and the probability of a certain event is 1 or 100%, and everything else falls in between there. Okay, we're also going on to section 5.2 right now as well, so doing 2 sections in one just because we don't have that much time left in the year. So what if we're organizing outcomes, and what if there's more than one event happening? So right now we're going to be looking at independent events. So independent events is when the outcome of one event has no effect on the outcome of another event. So for instance, if you flip a coin, the outcome that you get, heads or tails, has no impact on what number is rolled. So these are independent events. Their outcomes are not dependent on each other. Okay? Oh, and sample space is another term you need to know, because our question is, a coin is flipped and a 6-sided die is rolled. So 2 events happen. These 2 events are called independent events. And the sample space is all the possible outcomes, a list of all the possible outcomes of an experiment. Okay, so whenever it says sample space, it just means write out all of the possible outcomes. Okay, so there's a couple ways we can find these events that we're going to go over. So the first way is that we can use a table. So we're going to make a table, and we're going to have the coin. Let's say we can put it at the top. Doesn't matter where you put it. And the coin options are heads or tails, correct? That's all you can get is heads or tails. The die, oh, maybe I should have done this the other way actually, that's okay. So the die, which is short for just, wait, is die or dice plural? Dice is plural, die is singular. Yeah, so this is one die. We have how many outcomes? Well, we have there, you could get 1 or 2 or 3 or 4 or 5 or 6 could show up. Okay, so those are all the outcomes of the die. And the outcomes of the coins are at the top. So now on this table, when we make with just these two events, on this table, we can write out, and I'm just going to do it in a different color just to separate it. Good. We can write out all the possible combinations of these two events. So that's what we're trying to find, is this combination of events. So you could get a 1 and a heads, or you could get a 1 and a tails. You could get a 2 and a heads, or a 2 and a tails. You could get a 3 and a heads, or a 3 and a tails. You could get a 4 and a heads, or a 4 and a tails. 5 and a heads, or a 5 and a tails. Or you could roll a 6 and flip a heads, or roll a 6 and flip a tails. Whether you write the numbers first or the letters first doesn't really matter. Just keep it consistent the whole time. Okay, and now we can see we've written out every possible combination because we have both total possible outcomes for the coin, all 6 possible outcomes for the die, and we have every combination that we can get. So this is all the possible outcomes, so I use the table to list all the possible outcomes. How many possible outcomes are there? Well, there's 2, 4, 6, 8, 10, 12. There are 12 possible outcomes with these two events. It says write the sample space for this combination of events. For some reason, this chapter asks us a lot after you've made your table, and they just want you to write out 1, H, 2, H. Write out these little ordered pairs. And then 3H. You know, if I was just going down this way, 3H. You could have a 3 and a heads. You could have a 4 and a heads. And they just want you to write it out in these little ordered pairs. I'm not worried if you don't do that. I think this table shows our sample space well enough. Okay, so using the table is one way that we can find all of the outcomes of multiple events happening. There's another way that I like quite a bit, actually, and it's a tree diagram. Now, tree diagrams work for if you have even more than 2 events. Tables only work for 2 events. Great at showing the sample space for 2 events, but tree diagrams, you could do it more than 2. So a coin is flipped, and a spinner is spun once. So the coin is flipped, there's 2 possible outcomes. The spinner is spun, there's 3. So create a tree diagram that shows all of the possible outcomes. Okay, so a tree diagram, you're imagining that there's you, and now when you come to flip this coin, there's sort of 2, your future could branch into 2 separate ways. It could branch so that you flip a head on the coin, or your future could branch and that you flip a tails. Okay? Now, it could go those 2 separate paths. If you went the one path towards the heads, well, you could flip a heads, and then you could spin your spinner, and you could either spin to get a bear, spin to get an elk, or spin to get a salmon. So these 3 possible outcomes could have happened off of the side of you flipping your coin for heads. And then we could write those combinations beside. You could get a heads and a bear, you could get heads and an elk, or you could get heads and a salmon. Okay? Or if your path had gone down the route of flipping a tails, from there's three possible paths your life could take. You could spin a bear, you could spin an elk after you flip the tails, or you could spin a salmon after you flip the tails. So there's three more possible outcomes in the end of on those routes. You could get a tails and then a bear. You could get tails and then elk, or a tails and then a salmon. Okay, and those are all the possible outcomes. So now that I wrote them together here, this would be my sample space for these two events. So when it says list the sample space, I'm fine if you just have them listed like so at the end of your tree diagram. And these are all the possible outcomes. So there's 8 possible outcomes for this. What's nice with, okay, so tree diagram table is sort of the two that we're looking at. Okay, so we could have done this. Think of another diagram. We could have used the table just like before, but we didn't. What's nice about a tree diagram is, what if you had a coin, you know, with the queen on it? There's good profile and I found. There you go. What if you flipped it 3 times? And you could say, well, what's the probability of getting 3 heads in a row? That's what's nice about a tree diagram, because you start and you flip the coin. There's 2 possible outcomes. If you get a heads or a tails. Well, if you flip the heads, you have 2 possible outcomes. You could get a heads or a tails. Or if you flip the tails, you could get a heads or a tails. But then you can just continue this tree diagram into your, so this would be the first flip. Sometimes good to write that, right? So everything down below would be the first flip. Then you'd have your second flip. And then you could go into a third flip, because you could flip a heads, and then get a heads again, or a heads or a tails, or a heads or a tails, or a heads or a tails, or a heads or a tails. And so now I see this tree diagram branching off, and I can see all the possible outcomes. I could get heads, heads, heads. I could get heads, heads, tails. I could get heads, and then a tails, and then another heads. Or I could get heads, tails, tails. And I can continue seeing that. Or tails, heads, heads. Or tails, heads, tails. Or tails, tails, heads. Or tails, tails, tails. Okay, so that's all my possible outcomes. And I can see that there's 1, 2, 3, 4, 5, 6, 7, 8 total possible outcomes. Only one of them is getting 3 heads in a row. I could also say, well, what's the probability of getting 2 heads out of 3 flips? Well, there's, this one has 2 heads, this one has 2 heads, this one has 2 heads, and that's it. So you have a 3 out of 8 chance of getting 2 heads out of those 8 possible outcomes. Okay, and so it's just an easy way. I like these tree diagrams. If you have more than 2 outcomes or 2 events happening, it's an easy way to see it. Obviously, you wouldn't want to, it'd be hard to make a tree diagram if there was lots of different possible outcomes. So for instance, if you had like a 12-sided die, that would be really annoying to make, because you have to make 12 branches coming off the first one. Then if you rolled that again, you'd have to make 12 branches coming off each one of those, and it would be absolute chaos to make. It would take tons of space. So for simple events, tree diagrams work very well. And we'll only be dealing with simple events for now. Okay, so that's the start of our probability unit. Sorry that was so long. Yikes, 24 minutes. Okay. Anyways, hope that helps. There'll be a small assignment. Talk to you later, grade 7s.